Um, Good afternoon, everyone. I'm Hua Huang, Assistant Professor of Social Sciences, and welcome to the Illinois Tech Social Sciences Great Problems, Great Minds Seminar Series. Before I introduce today's speaker, I would like you to know you can submit questions during the webinar by typing in the chat box. We will open the floor to questions at the end of the webinar. Now I will introduce today's speaker, Dr. Shuming Bao. Dr. Shuming Bao is the director of the China Data Institute and Feature Data Lab in the US, and the co-director of the Spatial Data Lab project. He is also the co-director of the Geocomputation Center for Social Sciences at Wuhan University. He was the director of the China Data Center and a faculty member of the Institute of Social Research at the University of Michigan before he founded the China Data Institute. His major research interests include spatial economy, spatial statistics, and spatial intelligence. Dr. Bao has published more than 100 papers in the multidisciplinary areas of GIS, regional economics, and spatial data analysis in top journals, such as the American Journal of Public Health, ecological indicators, and the proceedings of the National Academy of Sciences. He received his PhD in applied economics from Clements universities. It's a pleasure to welcome Dr. Bao to have a talk.
Thank you, Professor Wang. And I just received this invitation actually yesterday afternoon. So I put together and some slides and I hope you enjoy that. But these slides were, and basically is kind of accumulated and what we have been doing in the last 3 years. And so my talk is an integrated approach for spatial temporal research, teaching, and applications. This is presentation actually, and it's put some joint effort by and many of our team members at Harvard, Wuhan University, also some other institutes. So the Spatial Data Lab project and is jointly sponsored by Feature Data Lab, Lime. It's a Germany-based company, and also Center for Geographic Analysis, and also George Mason University. It's also kind of have some partially funded by National Science Foundation for Spatial Temporal Innovation, the grant. So the goal of this project is try to build a kind of advanced platform for effective and collaborative research. So we have the different kind of the products and from this project include some spatial data connections and also sharing, and also the spatial data analysis platform and tools, and also build some workflow-based case studies. And also we have delivered and organized many training program and also there's publication of research papers. For the data scientists, or mostly, especially for spatial data science, there is some kind of research need and very commonly and by our faculty student. We're trying to get the easy data access, especially for frequently updated data, like some COVID-19 data, temporary data, environment data. And also we like to integrate the data from the heterogeneous, the resource. And also we like to have efficient data analysis visualizations, because we like to use a different kind of tools, not only stats tool, R, Python, ArcGIS tools, but really it's a kind of challenging, also time consuming to use a different tool for manipulated data and for data analysis. And also as data get big and bigger, how to access to the high performance computing, especially for spatial temporal big data. Now it's almost impossible to download all the data into my personal PC, then how you to do the data analysis. And also more important, how to make our research reproducible and replicable. And most of the papers and published on journals, we know has a non-big issue is those paper, the data analysis cannot be replicated, right? And cannot be reproduced. And also another important key issue is how to collaborate among researchers from different fields with different level of skills. Now we have the Google Docs, so people they can and work together on the same the file or data sheets. But for research, how can we work on the same research, the build the data process? Where there is already some the data service or tools for this kind of spatial data research, like some the ArcGIS Online, and also like some the one-stop shop, but the claim, and like some Google Eng or Dataverse to share the data, and also there's some data sharing connection by the geodata from the government. Those functions mostly allow you to download the data, including map data, and also allow you to querying and also the data, and also you can share some data editing and for GIS data, maybe online, do some online analysis and publish or papers or data, and also preserve the data. So those are current most you can see the available data service. Where there's a challenge here, where the challenge is here for those kind of data service and they need a high development cost and also very slow implementation, right? We have all the different centers, like some and IIT, even to develop a center's website or department website, it takes time, right? And also their high maintenance require professional skills, and also usually make of the flexibility for customize the research inquiries and change demand. So because as a web provider and the service or data research, data analysis, they already are fixed. It's not but our demand are changed all times, especially with many the new data and also new methodologies. And also there's some barriers in sharing with researchers and from different fields, different knowledge and skill neighbors, how to share research. I mean, not only the publication, not only the data, but the complete the analytical process for those research, from those research. So we have been working on this kind of approach. We call now an integrated solution for spatial-temporal research, teaching, and applications. So for data analysts, we use the workflow, the tool. So from the data access, data input to data analysis and visualizations. Now we can build it as a workflow. We can process the multiple tasks at the same time. And this workflow are completely and repeatable, reproducible, and also expandable and easy and to learn. And the results of the completed workflow can not only be run on the desktop PC, but also can be deployed to the web portal. So other people, once your workflow is developed, and once you deploy it, other users, they don't have to install the workflow tools. They can just go to the web, and like some web application, you can snap data or upload your data, and then build your own data analysis and generate different maps and charts and tables. So those kind of the online data analysis allow to provide a very efficient data support, research, training, and also even public service. So this is the technology we are using. And we have been working with Lime. The Lime is a German-based company, also split from the university. So the Lime is open source software. You can download it from the website, install without any fee. So it provides a kind of the new concept for data analysis. There is a different kind of nodes. It kind of by different functions are classified, built in different kind of the standard blocks. So you can put together all the different nodes together and configure the nodes. Say what kind of data you are going to snap for input, and what kind of data analysis we are like to select for the data analysis functions, and also how to visualize your data. So it can easily build a kind of your workflow for data analysis. And you can learn that in several minutes. But if you want to be a good expert, that can be a lifetime and a learning procedure, because there's so many different the functions, from the simple to very advanced, from just the statistical analysis and to the machine learning and deep learning. And also those nodes are still continue increase. And so that's a kind of, if there are some functions not available in the line, and we can always expand your new nodes with Python's, R, or Java. So based on those kind of technologies, and this is our some current appraisal work, and we have some data collection and sharing. We have been collecting data since the outbreak of the COVID-19 from the beginning of 2020. So now we have weekly update. We have the tool we are using is using working tool to download data from the different website, and then put all the data together with integrated with the GIS map, and then deliver that one to our Dataverse for sharing. So those procedures kind of we keep updated, and with workflow is much more efficient. Otherwise, if you use it manually to download data, integrate data, then deploy data, that can be very time consuming. And also it's very difficult to keep the data accuracy. The second one is we are being work with a different team for research applications for those COVID-19 data, and also other data almost from our different field. So we have built more than 60 called workflow-based case studies, and most of from the peer review publications. And then also our team member has been published more than 30 papers from those COVID-19 data, and also other data, mobility data, and sense data. And we're also working on some workbooks for textbook and the teaching lab. And those are kind of the two books, where one is by Luke Anthony, and Modern Spatial Economics, and another one is Qualitative Methods and Social Economic Applications in GIS. So there's many case study in their textbook, but the case studies are mostly done in spatial software or in the GIS. So you have to learn how to use the software and for this data analysis, for those case studies. Now we build workflow. Everyone can use the workflow and to do some advanced, from simple to advanced data analysis, and without any spatial software. And also we have been offered more than 30 different training workshops, and also more than 60 the public webinars on how to collect data, process the data, and also analyze the data, and on different topics. So here I just give some example, the demo of what we have been doing with this kind of the tools and also data. This is a project we're working on take a parts of China with a spatiotemporal approach, and based on multi-resource data and also the 9 workflows. So this the data come from different sources, from the government statistics, from the census, and that data can come from yearly data, month data, quarter data. Those GIS maps have the province, city, county, or even township boundaries. And also we have integrated some data from other resources, some environmental maps and remote sensors, and also social media and some survey data. So here are some data, and we're working on those government static data, remote sensor data from NASA. It's free. The human mobility data, and from different sources, and the social media data, and from GeoTwitter, and also review data. It's an online survey, the company. So here's some statistics looks like some GDP growth rate and CPI, and this data kind of updated monthly. And this Morris data, and it's remote sensing data from the NASA's website. You can download, and you can use a program to download data instead of individual to download it. And here's Weibo, it's a social media data. And in China, so the people post what they're like to post on the website, similar to the Twitter data in China. And this is Baidu mobility data called index mobility, and they also update almost every day. You can download from the website. And this is the RIWI, it's global survey. So they provide kind of and plug in the survey. And so they have the kind of survey across all different kinds of countries, and also some survey, keep the update every day. So this is some quantitative index, and also we'll see how the RIWI data with government statistics data, and what kind of correlation between their survey data and also the GDP growth rate from the government. And here's an analysis of how the survey data and with the CPI data, this is based on the monthly data, right? And this is, you can see how this is government statistics and most data necessaries, the temperatures and the change over time. And once you extract data, and we can integrate the data with a GIS map, and then we can show the dynamic maps of those the government statistics and temporary data from remote sensing data. And also we can see how this monthly change from the survey data and by the people's invest spending. And this is a panel data. And based on those data, once we integrate them together, we can build a model. And we can use a build panel data model, use a regression and a spatial regression. And so for those kind of data analysis, and for those kind of data connection and process analysis, usually it's a very time consuming, big job, right? For most of the users or scholars. So how to make those kind of the data analysis and from the connection and to analysis to delivery much more efficient and effective. So that's an everyone stream, right? So we are now use the NIME. With a NIME workflow, we can build a very simple workflow, but also we can build a very complicated workflow. So this workflow we build, we can access data from those data resource directly, and then build those data analysts will just see the different charts and maps and tables and models. And then finally, we can deploy the data process to the web portal. With the portal on the right, you can see this is, you can go to the website, just log in, and then you can snap this application. Now you can use the data on our server. You can also update, replace the data with your data, and as long as they have the similar format. So here is a kind of how this web portal looks like. So if you go to the web portal, you pick your data, then you can just run it. It's a workflow is actually and run behind your web portal on the server. You cannot see that, but it's actually run on the server. So you can see it comes out with different tables. You can also interactively snap some parameters, and you'll come out with the charts and different maps. So it comes with all the different kind of multiple outputs. This is kind of multiple task. And you can, if you like to change, say, the methodology, the model, we can go back to the NIME, go to the workflow tool, and just replace, just revise some part of that. You don't have to replace everything, right? So you just replace whatever you need to replace. So that can help us to improve our efficiency. And also it's easy to training. Even we can train from high school student and to the PhD student to postdoc. They can learn very quickly. And yesterday evening, we start 3 days training workshop. The 2 primary instructors participated, actually received our training And last month, we just give a 3 days training, and now they are expert, and they come to serve as an instructor to show the people how to design, how to build case studies, and also to show how to apply some new methodologies and for healthcare and study. This is another case study, the spatial study of tiny healthcare disparity and mental health. And similar, and this is try to access potential impact of the tiny healthcare disparity on mental health. So we have data from the different source, right? So now this is a chart for data analysis. So we have the sense data, and we have the network data, root network, hospital data, non-use data, also the sentimental data scores from the GeoTwitter. So with those data, and we can do some two-step floating, do a catchment area analysis, and then also some regression analysis. And then all this the analysts, they can deliver to the web portal and allow the people to upload their data or download also even workflow and do some online spatial temporal simulation analysis and generate and the dynamic report. And so this is kind of, you can see on the top is the workflow. And the lower part is the results and generate from the workflow. You can see the dynamic maps. And this is how it looks on the web portal. It's kind of interactive, the report or interactive publication or interactive papers. Now the paper, the report can be executed, right? Not the static paper or report anymore. You can see this is the report, and then you can pick up your data and you can generate, the pick also snap different the parameters. Oh, sorry. Okay, now you can see there's that generate different the charts and the tables, and the results come out. Okay, so this is how this integrated approach can make a difference. You can make difference. Now you can see we have the efficient development and also implementation of customized research the service, and also provide an easy maintain of the system without spatial security. Once you deploy to the web portal, you don't have to maintain. It's very easy. And also, it allows a greater flexibility on expansion for change demand, say for different research paper, different research topic, we can just customize, and this the workflow. And it provide, it's also no entry cost for learning and applications, and everyone can plug in. And even if we have the program skills, you can revise the workflow. If you have no program skills, you can just use the workflow, just know how to interpret the results. So everyone can plug in. And also it can promote reproduction and replication of the qualitative research. So all the workflow, everything here you can reproduce that, copy and paste, or save and load and then add the new data. It can facilitate multidisciplinary and cross-organizational collaboration. Those workflow on the web portals, and once everyone log in, and you can get from different place, you can edit, revise the workflow. Other people can see that immediately. So it's kind of Google workflow, not Google Doors. Well, finally, I here probably take this opportunity to do kind of leader kind of advertisement to what we are doing for China data, the research. So some new development of the China Data Online. So we have been working on this China data project since 1998, and with the China Data Center was established in University of Michigan, and for a long time, where there's another China Data Center actually before this. Our China Data Center is actually in Chicago by the University of Chicago, University of Illinois of Chicago, and then they exist for 3 years. So we have been working and develop the China data and deliver the many unique China data, and and also make this data online for China Data Online service. So now this China Data Online service has been available, actually has been subscribed by many libraries in the US. So it provides kind of comprehensive the data research for China research, and also is one of the most important reference resource for China research. They include government statistics, census data, and spatial data. And here are some primary database online, and 3 big database. One is the China statistics, the second is the census data, the third one is the spatial data. The China, this is our interface and gateway for China Data Online, the chinadataonline.com. And from here, you can easily get access to the different data on China. So this is China statistics data. The Chinese statistics data cover the monthly and yearly data at national, province, city, county levels, and also some industrial levels. And also we provide complete the data sheets from the yearly province statistics yearbooks. And those data sheets tables has been compiled in both English and Chinese. And you can easily search across the different tables. And also the statistics chart, and all this data can use a chart to see how the time series and change over time. You can manipulate those charts and also download those data into the Excel file and very easily. And this is a population census data integrated with the GIS maps. So we have delivered and developed a series of the census data with GIS maps. And from the 2010, 2020, and also some historical census data. These are pretty unique. And this is come from the country level, province, prefecture, city, and county, and even township level. Another big data product we have is economic census data, and integrated with the GIS maps, and from the different economic census in China. And also those data come at different administration levels from the province, city, county, and zip code, and also include more than 7 million firm level data. So this covers almost every industry, from the manufacturer to restaurant, hospitals, and also schools, and even the churches and the temples. So those provide very comprehensive information for China, almost for every field. And we just have a new release of the China Data Online last month. So the new release and give more and user-friendly function and for online querying and some online data analysis. So this is some new, with a new release, you can do some exploratory data analysis and without download data to Excel files, but you can download data to Excel files and easily. And this is China G4, and we integrate all the different data from different sources in a spatial system. And now you don't have to use the GIS, you just go to the website and click and snap the different index and generate a map or extract the data with the GIS map or do some spatial analysis, generate different kind of reports. And or for the, so there's a more than 6,000 variables for all China everywhere and different neighbors. So it's very comprehensive, and most data you cannot see in the paper publications or any other data resource. So we are now work with NIME, the Germany-based company, and to increase and the spatial, geospatial capacity of the NIME. The NIME is a workflow-based software, but usually it's mostly for time series data. Now we are going to release actually next month at the NIME Summit. You call it geospatial analytics. So this analytics will provide some basic functions, how to input the GIS data, how to visualize the data, and also how to manipulate different spatial operations, and also for spatial data analysis, spatial modeling. So that's the first release. We're going to release the next month. This will join with NIME and also with the Center for Geographic Analysis in Harvard. So the purpose for next direction, and we are continue our technology development will continue to build and more new unique data connections, added value data connections, and also to apply those technology data resource for research and application. And we're not to promote this, and not only just we can do by the team members, but we're not to build a global network affiliate labs to provide a platform for everyone. And so this is the affiliate labs. The idea is you can build your affiliate labs, everyone can build your labs. And also, or maybe you can build a kind of collaboration between your current lab or center and with our core team at Harvard. So as an affiliate lab, and affiliate lab will work together with our core team to properly connect and build your data connection or featured kind of data index or derived data index and for your lab for research. And also participate in the development or test our spatial nodes and case studies. And that's kind of very good start from learning. And then participate in the development of new case studies and build on your research. And or then organize or participate in the public webinars or training webinars and on spatial temporal analysis. And then apply the spatial data lab technology and case studies to your research and teaching. So that's we expect this kind of task for affiliate labs. Then what we provide, so our spatial data lab will offer some central and fundamental support and to those affiliate labs. And that's including we'll have the leadership training and technical training. And this week we have the one training on the spatial temporal, the study of healthcare accessibility. And next month, we'll have the training of the spatial temporal study of the social media, the data for big data. So we have a series this training for leadership for our affiliate lab. And then we also provide training for our updated the technology, we are working on before the release. Then we'll be training and test and use those new technology. And also we provide a shared case study database. So we provide those case study cover almost all different kinds of topic. So you can use those case study, build your case studies. And also we provide some research data support, including some geotutor data connection we have at Harvard, and some web data connection we have at Harvard, and also some survey data from our partners and China data online, and those sense data from different sources. So also we provide technical support. So if you have a difficulty to build your workload, we can provide a technical support, help you to build your workload. Then you can start from there and to expand and learn by your team. And also we promote the achievement by the different labs. So we have the different kind of webinars, and also we have the platform and to promote the publications and also their teaching and also trainings, webinars organized by the different labs, because we are a global kind of network for those deliver and those information. And also one important, we recognize those achievements by different affiliate labs and members on our spatial data lab website on the Harvard, the server. So that's the idea for the next the development. So with this kind of the technology and with current the data connection, and we can hopefully and hold the faculty member and the student can join us and to expand the research and teaching and in the field of the spatial temporal areas. So this is our website. Or any questions?
Thank Dr. Bao for his very interesting and also interesting cutting-edge technologies, introducing these cutting-edge technologies and methodology. You are working on to integrate all these spatial data from different sources, and also integrate all the research, teaching and learning together. So currently we just open to the questions. So I think my first question is, I think the affiliate lab that is very attractive to the person. I think it's very attractive to person want to use this data. So I'm wondering for this is application is like regular or is anytime can apply, or could you
Well,
give more detailed information?
Yeah,
about
very
that?
good question. And we just started the process, the first application, and this week. So we have a presentation from the 6 different apps, and those the people are usually most are kind of participate our last month of training webinars. So we have the 6 apps and lead by most by faculty. Also, there one by the graduate student, the is a PhD student. So those apps are covered in different fields, different topics. Like some, one apps on the social media, one app on healthcare, and one app on the focus on the industry data, business data, and one app is on the criminal, the justice, and one app is built on geocomputation for social science, and also one app on built on the urban renewal, the studies. So all the current different the topics, and what we provide is we provide some the initial kind of seed workflow, and also we provide a technical support if so they are training, they just learn the name, but if they have them difficult and in field their workflow, we can help. And so if there's some technical issue we cannot solve here in our team, then we can forward to the NIME, to the company, because we have the weekly meeting with the NIME. Like this morning, we just have the weekly meeting with them. So we can always get the first hand and the most strong support and from the top companies.
Okay, that's very useful information. Jeff, you have more questions?
Hello, thank you. Great talk. I just have a question about the use of multiple sources. When you're using multiple sources and combining that, how do you handle differences in data quality, collection quality? How do you even know those differences exist? And I just wonder how you account for that.
That's a very good question. And where for the data, so we have mostly it's not just graph data, right? It's usually we already have some experience usually with the data. Say like some the Morris data, it's a kind of standard image data. So we're kind of there's a different kind of methodology how to and process that data to extract data from the Morris data, or some data they already have to process that to share on the Morris data on Navarre's the website, and then use temperatures. So you don't have to say where you can keep changing, but that's kind of data many people are already using. So what we are doing is to extract data or aggregate data and at different administrative levels, so they can integrate with the GIS map. Like some for the sense data and from China Data Online, sex data, this is from the government resource, and we're not challenging their standard. And even the people, some people say if there's accuracy, but that's not our the task. We're just take the data from the government and release and then integrate with our GIS maps. And then for some social media data, and there's already there are very mature methodology, say how to and computer kind of sensitivity, sentiment, the index from those social media data, from the people's post. What we need to do is we're extract their the locational information, and then build integrate those locational information and with our maps, so they can work with other data together. I'm not sure if this can answer your questions.
Thank you. Appreciate it.
I think we have a question from the chat box. So it's given you are dealing with a country with many border disputes. So how did you deal with the national borders of China?
Okay, so the maps we are using and from the government resource, we are not develop the map used by ourselves. And also the reason we are using the official maps, I mean the base map from official the resource from the government is because we are working on the China data, right? Say we don't want to have the dispute say with say Chinese government on those say boundaries. Otherwise, our data center will not be able to even get the data, right? So integrate the data. So we are usually we are not to, and so the data will be consistent with the government standard from the sense data, statistics data, and also the boundary data.
So I also have another question is about the business data. I think you're showing it's millions of firm level data. Is that the data is same as like industrial survey data, or is different from?
Oh, that's a different. The industry survey you are talking about is usually only for called mid and large size enterprise in China. So in 90, probably in 2000, around 2000 or 2010, there's about 400,000. This kind of called the mid and large size of the enterprise in China. The business data, and we talk here, is from economic census. Economic census is only every 5 years. They cover almost every business from the third the industries, from the service industries to manufacturing. So the industrial survey only cover those big meter size of manufacturing. So there's about more than 6 million, right? From 2004, probably about 8 million in 2008. Now it's over 10 million in 2018.
I see. So which means it's population data instead of sample data.
Well, this is not sample data for all the complete coverage.
Oh, okay. So then it will be dynamically every 5 years will be.
Yeah, right. Every 5, but not every 5 years it can release all the individual data.
Oh, okay. So that
it's more now. It's more kind of the not easy. It's more and more difficult to get the individual data. Yeah.
Yeah, but it's if it's for the whole country, then it seems for the industrial survey data is, which means for this business data also includes the industrial those companies.
Yes.
Oh, okay, I see.
It's much larger than that industrial, the coverage of industrial survey.
I see. That's pretty good data. So and also I'm wondering, so since you mentioned like for the multi-source data, besides like the quality and also how often frequency this data can be updated, it will be how actually integrate.
Yeah, it depends on different data source. Next some COVID-19, and we update every day. Next some government statistics, they update some monthly, some quarterly, some yearly. So it depends on the different data source. Next some for the NASA's bodies data, they update actually every day. So you can always get the most updated the image data from NASA's website. So those data and also Twitter data updated every day. You can do, yeah. So depend on data source, yeah.
I see. So then when the integrating this process is also when they update your data, integrate is also updated.
We're not say every day or the data every day, not every day. But mostly some where the government stats is based on how they're released. And if they're released, then we can keep update on the China data line. And on the Harvard Dataverse, and we keep some data connection, we update a URL every week. So we have every weekly meeting, and they can run their workflow and keep data updated every week, not every day, because those are by volunteer, by our volunteer to work on that one. Yeah. Yeah. So yes, free for the sharing. Yeah.
I see. And also, do you have for this integrated data also include like a commercial data or is like a government data?
You mean the promotion data?
Commercial
data.
Yeah.
Oh, okay. There's a when you say the commercial data is a kind of fee-based data, right? Or the fee-based data. Where like some China data online is subscription-based. And then for the many COVID-19 related research data, it's not fee-based. And we'll go to the different website, and some companies there and offer share some data for free for COVID-19 research. Now there are many companies that are kind of pretty generous, like some Baidu mobility data, and they start to allow the people to download their mobility index since 2020 after COVID-19. And but before that one, they are not open. And we're not sure after COVID-19, they're still keep open. And also not some Google data and also Apple and also some other companies, they also provided some free data for people to download online and for free at this time. And basically you can find how many people say go to the different grocery stores and how actively people kind of move around on the ground.
I see. So, and then do you have plan like include some like commercial databases?
What you means includes the commercial database?
Yeah, in the future, like integrated some like it seems currently using is more from like a government than from the online commercial. And then do you have a plan like use like some commercial database?
That's a good question. The Rewe data I present here for Tech Parts of China, actually it's a commercial company. It's a Canada, University of Toronto, and spin off the company. So they developed this kind of technology for plug-in survey. It's kind of the fee-based service, but they can provide an on-time, the most updated time, the survey data. So they have this kind of survey across our different world. So they're kind of considered as a commercial, the data companies. And we'll work with them to build a kind of added value and with their data and also with some other data. And for those people and for the different users, yeah.
I see. Yeah, I see. Because I saw it seems to also include like some like Chinese like Baidu this database.
Those data are actually right now free. Yeah. But Rewe data is kind of the survey. It's a new kind of technology for how the people can get the most updated survey data. And especially like some people's opinion, the price, expenditure, those, because most of the survey for household survey, we always, when you get the data, it's outdated. It can take a month or yearly to collect data, process the data, right? So their survey can always get the, most of the current data. So that's a kind of new technology and we are being working on.
Yeah, that would be very useful and helpful for people doing that research.
Right. So the faculty can build this kind of the technology into your grant proposal, right? Instead of go to use the traditional way to connect data, and that's a high cost. But with the new technology, so you can integrate this kind of technology and into your grant proposal to lower down your survey cost. And most importantly, get this kind of time series And also they have the spatial information, locational information, where the people's kind of the answer respond to the survey. So that's also another very important features. And all these are not confidential since they responded on the website. So very, very good for those that very different from traditional survey.
I see. Yeah, that's very efficient. I think the current I saw yesterday and some like a website provider is like the build of the website is like to do the survey. Then it's not just like as we did before, like go to log people's door to do the housing survey. It's just by internet. Actually, one question, it actually can get billions of persons' opinions, even include the experts and expertise.
Right.
So I think the other question is about the API. So like a Dataverse API. So if more people want to use that, it's also by affiliate app or the lab, or it's actually can free to just use the Dataverse API to do some like a customization.
Yeah, so that's the kind of the technology. Many people now share their information online, so you don't have to download everything. So they give you an API, you can get access remotely to the data and also to some functions. So with the API, we can also use a workflow. You can use their API, build in their API, so you don't have to download their data. You can use the API to get access to their data directly. Not some Dataverse, they offer the API. The Earth, they offer the API. So there's many the data series now they offer the API to allow you to get access to their data without download a complete data set.
I see. Oh, okay. Yeah. So I think some quite a few provide this API to do like some like a programming to do some certain analysis for that. So I think another is the I think that I feel it's very unique part is the NIME geospatial that workflow. So I think for that workflow is kind of it seems that didn't see from the previous methods for the spatial data using is NAM the workflow. So could you give more detailed information? Like this workflow is we can, like if people want to use the data, like this workflow, they can just use the component or how actually?
It's a kind of extension of the NIME. So you need to install the NIME first and then load this extension. So we call the traditional NIME, they don't have the spatial capacity, right? So with the new, the geospatial analytics is kind of extension of NIME. So NIME is a kind of the platform and a kind of provide platform. They have some core function and basic functions integrated when you download it. But there are the thousands of the other nodes, kind of the functions not included in the basic tool. So you can get those nodes and from the NIME hub. And also, so this geospatial analytics will be on the NIME hub. It's free. You can download it and to the NIME tool and then apply that, use that one, build your workflow. Usually you have to probably use some Python program and build some spatial data analysis. That's kind of challenging because the NIME, the different versions of the Python and NIME may not work together, right? So you need to figure out how they can work together. So with the geospatial analytics, this can allow the user to easily build their workflow for spatial data analysis. then you don't have to use it. Also, you don't have to use the GIS software. Yeah, you don't worry or concern about the other software.
Oh, okay. So which means that they are can just download this extension. So they have these nodes, so can be
Yeah,
used to work on the features and
yeah, it will be built in Lime and in the future.
okay, I
Yeah.
see. It's like a module. So each module.
Yes, right.
Okay, I see.
A group of module. Yeah.
That's great design actually.
Uh-huh.
So and the other question is wondering how actually for this data the China data online. So if how to subscribe for this the service.
So if you go to this chinadaTaCenter.net and for the first web link, so you can find.
You can actually you can show us.
Oh, okay. If you go to this website. Oh, this is spatial data app. This is a China Data Center website. So if you go to the China Data Center and website.net, you can find the instructions for online the data subscriptions. You can see the kind of description of different database, and also there's an application form here. You can forward or recommend this to a library, and then we can also set a free trial and for the campus access. So it's very straightforward, yeah.
I see.
So if you click here, you can see there's the application. So there's the application form here. It also has a comparison of where's the difference between different database. So you can see for statistics data, sense data, spatial data, what's the different coverage and what covered by different database. Yeah. Okay.
Okay, I see. So which means can subscribe based on the data set instead of the whole.
Right. We have 3 different databases: statistics database, sense database, and also spatial database. So you only subscribe by each of 3 the database.
I see. And also, I think just now you mentioned actually for this project, it has different lab. So like there is like a social media lab, or there's like a health lab, and also different labs. So then for these labs, the data is also can be this data is more like for affiliate lab, or is more based on this China Data Institute.
Okay, this data collection is different from the China Data Institute. Luxem GeoTutor data is hosted by the Harvard, by the Center for Geographic Analysis, and they crawl the data all the time. So there now has many TBs of data. So those data they cannot share arena data and with external users. But so we work with different scholars from outside, and they can build a workflow with sample data, and we have the core team member to run the workflow on the server and for our affinity data mapper members. Yeah, so that's a way they can also to use the data on the server.
I see. Thank you so much for giving us a great talk to introduce all the wonderful work. I think you are working with Harvard University and also NSF on this project to give us a comprehensive, rich, and unique information about the China's and also spatial research. So usually we give for the speaker applause.
All right, thank you.
And for the great talk. So thank you so much.
All right, thank you. My pleasure.